Hello guys, how are you? So in this session we are going to learn all those interesting things related to data science, and specifically I am going to tell you about the natural language preprocessing, and it's related to the unstructured data. And I hope you will enjoy, because in the recent times, though there is a structured data, but the part of structured data is only 10%, and remaining 90% is the unstructured data, and you have need to do a lot of works on that unstructured data. And for that, basically a natural language preprocessing has been immersed, and through that you can do a lot of things. Recently how Google's or other YouTube's or other websites, how they are giving whatever you are searching within the second. Suppose if you try to search just one or two words, automatically they are suggesting next sentence. Or whenever you are trying to do a daily WhatsApp message or text message, then automatically you will get to know how it's that keyboard is suggesting all those types. So it's nothing but the all those trained model on the given data, such as BERT, lstm, then GPT, and transformer. There are so many all those models. So today, basically, I'm going to give you a small idea overall how it's working and how it's important, and also I'm going to give you a basic principle behind this, how it's working and how it's really useful for us. So without wasting your time, I will start with the NLP. And basically, in the previous video, I have also teach you all those parts about the data science journey, how to become data science, what things required for to become. So once again, I will repeat something that you should must know the Python, then MySQL, then you should know in the Python that list, string, tuples, file, folder handling, pandas, numpy, those should be must. And after that, in the machine learning, you should know the various types of machine learning, such as supervised, semi-supervised, unsupervised, and all those types of machine learning. And also in the deep learning, you should know the artificial neural network, convolutional neural network. And if those things are sufficient, then I think you will quite work well with the data science. And after that, you also need to learn all those recent development and technologies which are now emerged. So I'm going to tell you all those technologies and things, and how those can be helpful, and what types of projects or what type of work you can do basically by using them. So let's start with the NLP, and I have thought about you that NLP, how it's working, word embedding, and what are the its various models. So without wasting your time, let's start with some basic parts of the NLP, and I will tell you that how it's work. So specifically, before that, starting NLP, you should know all those things, and I will going to make some notes here. Just wait. And in that NLP model, you should know some things, such as, just wait, I'm just searching for that my recorder. Okay, so here are some issue. I will tell you initially. uh, my phone is some problem is occurring. So basic some things for the NLP you should know about that: word sentence tokenizer, then sentence tokenizer, then word tokenizer. So it's nothing but to splitting the sentence and to splitting the words. Then you should know very well about the lemmatizer. Then there are various types of techniques, such as lemmatizer, then other methods also, which will going to give you root mean of the words. So you should know very well about that things. And after that, you should also know the various things, such as word to vector, then TF ITF, then count vectorizer. So those are the techniques which will convert the meaning of the words into the numerical format, because you know that machine learning is basically working on the numerical formats. So count vectorizer will nothing but it will just convert, give the number of occurrence to the each word, and according to that you will get the matrix, sparse matrix format of documents, which will going to give you the repeated numbers of words, how many times that word is occurred. But it's not very useful as such a drawbacks for the count vectorizer, such as it will not going to give you semantic minutes. There is also issue about the out of vocabulary word. suppose two documents containing the same words, and if another document is containing different word, then that word will be not going to calculate it. So overcome that issue, there is another one method come, and it's called TF-IDF, and the full form is that term frequency inward document frequency. So it's the nothing but the product of the term frequency into inverse document frequency, and through that you will get to know that if suppose if some words are repeated very less time, then by using that logarithm and product of them, you will get the uh, more important weightage given to that word. And if the word is occurring many times and more times, then there is a less weightage given to that word, and that word has been specifically dropped. So here, as compared to word to count vectorizer, in the term frequency there is a importance of weightage has been given to the words, but still here is a no cosine similarity found between those words, and here is a drawbacks that if two words are nearly equal, such as king or queen, then still it will not going to predict all those words. So overcome to that drawback, there is another method of word embedding games, and it's called the predictive modeling, and it's related to based on the deep learning, which uses the artificial neural network, and through that it will going to give you the correct cosine similarity between the words. So it uses the various methods such as skip gram approach and bigram approach. So how it's basically works, it consists of input layer, then middle layers, and there is output layers, and it's also uses the softmax functions. So in the skip gram approach, what happens, it will put the single word into the middle, and it will try to find the adjacent words vectors, and it will going to uh, evaluate all those words into the middle one words, and it will try to predict how those words are nearly equal to each other. And also there is another one bigram approach. Through that you will get to know that how other words are similar to this one. So word to vector is the best one, and it will going to give you cosine similarity. It will going to generate the word vectors, and based on that you will going to calculate which word will going to come before or after the given words. So, but still here are various issues found in the word to vector, that it will not going to capture larger words, and it has a drawback such as it has a memory issue. It will not going to use for the language translation, because it will not going to remember all those things. So based on that, there is another system has been come, and it's called as recurrent neural network. And the most important things about the recurrent neural network is the we can consider it as a sequence. So it's based on the sequence, it will going to consider and remember the sequence of all those words, and based on the sequence it will going to give the some word as a number positions, and based on that it will going to give you output. So for the language translation, it is used before 2015, because there were no models present such as bert or lstm. But for lstm there were also a lot of drawbacks, because it was not going to calculate the context of the words. Suppose there are two similar sentences, that I am standing on the bank of river is one sentence, and let's consider another sentence that my bank is not providing me good service. So here is a bank word is totally different in both of the sentence, and here is a totally different context for those words. Still, RNN will going to consider that bank as only one meaningful word, and it will going to predict it as either river or the bank, and it will not going to consider as a separate one. So that was the largest drawback of RNN, and also memory issue. So overcome to the RNN, there is a latest and advanced technology scheme, and it's called as lstm, and long form of lstm is large short-term memory. And advantages of that it will going to capture the long terms memory and sequence of the words, and it will consist of that 10h functions, then softmax functions, then sigmoid functions for the classification and to give the number to the various words. But in the lstm also some drawbacks, that it was based on the feed forward network, and there was no back propagation, means it was not taking the words from the right side and left side at one time. So that's why it has also various issue. So to overcome the LSTM, then there were more and lot of research goes on in the industry, and after that LSTM there is a one best method has been come, and it's called as a transformer, which is developed by the Google, and based on that transformer consists of the encoder and decoder, in which encoder and decoder have various and multiple types. So I will tell you what encoder will do. Suppose you want to translate the Hindi language into the English one, then you will give a Hindi language to the encoder, then encoder will going to apply various layer that mm, that mask out, it will apply the mask out layer, then it will going to use the feed forward layer, then it will use the normalization, after that it will use the optimize function to normalize, and after that it through the linear function it will going to give the output, and the output has been came from the encoder will given to the decoder, and decoder will also work similar to the encoder, except here is a one extra added, and it's the mask input language added layer. So I will tell you what is mask input language added layer. So in the what happens in the decoder, suppose if you have given one statement, I like a mango, then in that decoder automatically it will going to mask that mango word, and based on the other sentence and given context it will going to predict that word. Suppose your model predict the mango word accurately, then it will going to give model as a perfect one, otherwise it will going to train that model and it will going to learn that model once again. So that process automatically happens, and another other advantages of that decoder and encoder is that as compared to the LSTMs, that LSTM was working only on the one side direction, so that encoder decoder or that transform works on the at a time on the two directional or bidirectional, and at a time it was taking the context of from the given all those passages or whatever data you have given. So at a time it was doing the parallelization processing. That was the major drawbacks of that RNN LSTM bidirectional LSTM. So because of it was taking an context of all those data at a time, so it has a very useful memory, and it was also going to predict or if similar word is occurred in different sentence at a time. The example I have suggested you at the recent time, that I am standing on the bank of river and my bank is not giving me a good payment service. So at that time, that transformer through the encoder decoder, you can predict very well all those words. So that is the magic, and through all that you can also translate language very easily. Also you can do all those summarization of text, and through that you can also use various your industry domain types projects, such as name entity recognition, that classification type, multi-classification type, language translation. Then you have need to predict the outcome of any word or to get the summarization of all those results. So that's the magic. So based on that transformer, various models emerge, and most of that are the BERT, then GPT, then other models were also consist of, and those models are emerging. So those are the best disadvantage, not disadvantage but advantage of transformer. But still there are some disadvantages, that what happens whenever we have given all those text to the transformer, still transformer we are lagging at some specific parts, and it was still not going to get the whole data. If you give the huge data, then it will not able to remember all those. So there is another advanced model of transformer has come, and it's called as Excel transformer. So in the data science or NLP, what happens if you face any drawbacks or anything, then so many research is going on, and there are a lot of tools, libraries, packages are coming in, and those are solving all those issues very well. So I hope you have enjoyed all those lectures and how all those things are happening now in the industry and how those are working very well. And after that lecture, I'm going to give you a detailed explanation how that transformer are working, how LSTM working, how RNN is working, and how those can be useful. And through that, what type of projects you can solve and how you can utilize all those tools, techniques by doing all those codings. I will tell you. And yes, by using various project, I know you will face a lot of challenges how to do some basic coding or how to part. And for that, I will going to give you some tricks, techniques, whatever I have learned, and Also, I will share some knowledge with you. So I hope you have enjoyed this video, and if you have any doubt or anything, please ask me. And in the next video also, I'm going to give you a clear detailed explanation about transformer, then bert. Then there are various types of birds such as robot, then mini bird, large bird, small birds. So there are various pre-trained models of the birds, and also there are various others models are evolving which using the birds such as, and there are various techniques or libraries are evolving such as Spacey or Spark, and those techniques can be very helpful for us to do all those our projects, and through that we can also do very good process, and we can utilize all those in our domain so that we can increase our efficiency and we can also learn all those things. So please tell me in the comment how you feel about that explanation, and sorry for all those disturbance, and thank you very much. Bye bye.